Welcome, dear listener, to another episode of Unveil the Future podcast. I am Van Nguyen, and it is a pleasure to have you joining us again on the second episode of this series. And for today's episode, we dive into the dynamic field of artificial intelligence and robotics, a transformative technology reshaping industries and societies. With robotics projecting to become the next multi-billion-dollar market in the next decade, we are honored to welcome a pioneer in this field, Professor Daniela Rus, Director of the Computer Science and AI Laboratory, or CSAIL for short, at MIT, and also the newest member of the VinFuture Prize Council, to join us for a very special session to delve into the prospects of this robotics revolution. Good morning, Professor Rus, and it is an absolute pleasure that we welcome you into the VinFuture Prize Council this year. So, given that the 2024 VinFuture Grand Prize recognized and honored the transformative contribution to AI revolution in the most comprehensive way, we are curious about your perspective on joining this initiative that honored contribution in this field.
Well, it's really exciting to see the recognition of AI and to see this kind of global honor that will be bestowed on AI researchers and in fact on the advancement of AI. And I think this existence of this award is significant because it really highlights a transformative potential of artificial intelligence. It underscores how AI is doing good for humanity and for our planet. It underscores the scientific foundations of this technology that has arrived at a point where it can create so much impact. And so it's exciting to see the recognition of outstanding achievements of researchers in the AI space. Well, I expect that we will be very focused on celebrating extraordinary achievements and identifying contributions and people who have made those contributions that could serve as a rallying point for young people, for researchers, for developers, that could really inspire the world to do more with AI.
So you mentioned AI's incredible impact in the digital world, and now we are bringing AI into the physical world through the contribution in robotics. The potential seems limitless. So from your perspective as a leading innovator in AI and robotics, can you share some of the most exciting recent developments in robotics and how they might change the industry in the next decade?
Well, let me talk about AI and robotics first, since this is the focus of the current prize. And so I will say that right now I see AI and robotics as different fields. I see AI as having extraordinary capabilities, primarily in the digital world, and robots have extraordinary capabilities in the physical world, but robots are not intelligent. They're largely pre-programmed. And so to me, the objective is to bridge this gap, to bring AI's extraordinary capabilities at understanding text, video, images, and other online data to make real-world physical machines intelligent. And these physical machines can be robots, but they can be other kinds of machines. They can be power grids, they can be sensors, they can be satellites, they can be, anything you want in the physical world. And so to do so, we really need to develop a different kind of AI, and I call it physical AI. And so physical AI is when AI's power to make predictions, to understand patterns, to do learning and reasoning with online data can be used to make real-world machines smarter. And so this requires certain advances. This requires that today's AI solutions be extended so that they understand physics and they understand how the world operates. And Right now, we have methods that are primarily statistics based that do not understand physics. So we have to do something more in order to get those techniques to work in the physical world. Also, today's AI uses enormous amounts of energy, and it uses server farms. But if you want to run AI on safety critical applications, there is no time for cloud calls. And that means you have to put the computation on the body of the machine. And that actually requires that we rethink the AI models because models on the body of the machine. And then the other thing I would say is that today's AI also makes mistakes. And for physical world applications that are safety critical, we cannot afford to have mistakes. And so to me, the question is, how can we develop physical AI? How can we create a new generation of AI solutions that are compact, that understand the physics of the world, that are causal, that do not make mistakes, that fit on the body of the machine? And this is something very exciting. My research group is engaged in developing physical AI. And there are other efforts in the labs of my friends at other universities and research labs across the world.
From diagnosing disease to making transportation easier and safer, your work has touched so many critical areas. So I'd love to hear more about the next frontiers you see in AI-powered robotics.
So I think we have enormous potential for using the extraordinary AI and robotics tools to help people with cognitive and physical work. So, of course, the digital AI methodologies and solutions are amenable to cognitive work. The robots are amenable to physical work. And together, I would say that these technologies, artificial intelligence, machine learning, and robotics, have enormous potential. We have the potential to better diagnose, monitor, and treat disease. We have the potential to ensure that there are no road fatalities and to make our transportation system much more efficient and effective. We have the opportunity to enable everyone to communicate with each other without understanding each other's language by using instantaneous translations. We have the potential.
Intelligent robots has tremendous benefit, but at the same time, there are many concerns about job displacement or ethical challenges, which are also the concerns of our 2024 VinFuture Grand Prize laureate, Professor Joshua Bengio. So how do you think that we can strike a balance between the benefit of robots while ensuring that these challenges are addressed?
To keep your information private and safe. In general, we have the potential to offload the routine tasks to machines and empower people to spend more time on strategic and critical thinking and on the tasks that are more enjoyable for people to do. And so I think it's important, though, to understand that the technologies that we have today in AI, machine learning, and robotics cannot solve all of our problems and cannot take on all of our tasks. These are extraordinary technologies, and there are areas where we have good fit. But then there are also new challenges for which we do not have yet solutions, and we need to do the research to get there. And I am especially excited about increasing the reasoning capabilities of machines, whether they are in the physical world or in the digital world, and also making AI energy efficient, because in order for AI to support us with so many possibilities, AI consumes enormous amounts of energy today. And so the question is, what can we do about that? Can we rethink how we develop and deploy AI so that it does not have such a huge energy cost. And our work with liquid networks and Linux networks really aims to answer some of these problems. These are physics-based approaches to AI that result in compact solutions that are not as energy hungry, that are provably causal, and that can be deployed in safe and effective ways.
Given the rapid advancement of AI, how do you see the long-term impact of intelligent robots in education and workforce training? And what key areas should we prioritize to prepare the next generation for this revolution, ensuring that we harness all of its benefit and not getting...
Look, we are in the 21st century, and I think it's important for us to embrace digital literacy. That means everyone should know something about these technologies. And when you think about AI and robots deployed in the physical world to help with tasks, the way to think about it is that we now have some new tools. And these tools are extraordinary, but these tools are not intrinsically good or bad. These tools are what we choose to do with them. And I think we can choose to do some extraordinary things. But in the process of doing that, it's always humans and machines working together because humans alone and machines alone are not as powerful as putting humans and machines together. So this means that people have to understand the new tools. And anybody can understand the new tools. This can be done through education programs, whether they are deployed in schools or in companies or by communities. And right now we have so many free online resources for people to learn more about these technologies.
Professor Rus, you and Professor Fei-Fei Li, our 2024 VinFuture Prize laureate, were named among the women driving the future of AI. So I was wondering, can you share with us what initially sparked your interest in artificial intelligence and robotics in the early days?
Well, so as a kid, I really loved reading science fiction books. I especially enjoyed the books of Jules Verne, and I was dreaming about a world with all these extraordinary superpowers that we fantasize about when we read science fiction books and watch science fiction movies. But I wasn't really focused on working in this space. I went to college and I studied computer science, math, and astronomy. And then at one point, I met my future PhD advisor, and I met him at a talk he gave. And his talk was very inspiring. In his talk, he explained how many of the classical computer science problems had solutions. And now it was time for the grand applications. And the grand applications included computation for interaction with the physical world. And that was a kind of an extraordinary realization and an extraordinary opportunity for me to join him to develop new kinds of computation that are not necessarily contained in the clean world of a computer system where everything is deterministic and discrete, but rather that have to deal with the messiness and the continuity of the physical world. And so I went to Cornell University, where I joined John Hopcroft, and I worked on robots that interact with the world in ways that are inspired by how humans interact with the world. So for my PhD thesis, I worked on some new robotic hands that were just being introduced. And we were getting these hands to do sort of in-hand manipulation, the kind of dexterous maneuvering that our human hands are so capable of doing. But interestingly, at the time, we did have these new hands that were inspired by the human hand, but their capabilities were not so advanced because they were a little bit heavy and the motors were not so strong and they couldn't exert the forces and torques that you and I can exert through our hands. The materials were all rigid and they were metals or rigid plastics. And that put some constraints in the kinds of forces and torques you can exert if those are the materials. And so after I finished my PhD, I reflected upon some of the limitations of the technology. I also reflected upon the fact that the machines that we have today are mostly inspired by the human shape. They're humanoid shapes or they're robotic arms that are inspired by our arms, or we have boxes on wheels. And they were mostly made out of metals and hard plastics. And don't get me wrong, we have these industrial manipulators which are extraordinary. They can do so much more than what people can, but they remain isolated from people on the factory floor because they are big and heavy and danger to be around. And so I started wondering whether we could have a different kind of robot, because when you compare what we have in the industrial world with what we have in nature or in the built environment, we have so many shapes, we have so many materials, we have animals that come in many different shapes, we have things that we have furniture, we have other things we have built for ourselves, and we're using so many materials. And so I became very interested in this notion that we should expand our idea of what a robot is to consider a wider range of materials and a wider range of shapes. And so in my lab, we have pioneered the early work in soft robotics, and we have looked at using silicone, paper, even food as the basis for making new robots. And this has opened up an extraordinary range of opportunities and questions that we could pursue to advance the knowledge and to advance of what we can possibly do by creating these new machines. Now, in the process of doing this, I also realized that a machine has a body and the brain, and the body and the brain have to work together. The physical machine can only do what the body is able to do. If you want a machine to climb stairs and you build a wheel-based machine, you're not going to solve your task. And so it's kind of interesting to think about the role of the body in the kind of tasks that it can solve. But a body, a mechanism without a brain to control it so it can meet its full potential, is just an inert thing. So in addition to the body, we also need to think about the brain. We need to think about the software that is needed to get the body to do what it's meant to do. And so I have been very interested in how do we bring capability by bringing the body and the brain together. And studying these machines has really taught me that we have so much opportunity and we have so much more left to learn, not just about the machines, but also about ourselves.
Such an amazing journey that you have captured. And I'm also interested to know that has your scientific journey has always followed a linear progression, or have you faced any setbacks that require resilience? And how can you elaborate on how you managed to overcome these challenges?
There are always challenges, but the path is never linear. I think we really have to focus on a very big objective or a very big goal. And for me, this goal is a future where machines help people with physical and cognitive work. And machines are pervasive. They're not curiosities. And so in doing this, my technical objective has been to contribute towards the science and engineering of intelligence. And the questions we ask really depend on the state of the art and on what is possible, or like, what is the next step where we can push the boundaries. But in the process of doing research, you find that some of the problems you thought were hard are actually easy, and some of the problems you thought were easy are actually hard. And you have to sort of adapt to wherever the science takes you and wherever the engineering can take you. There are actually a lot of extraordinary women in computer science and in artificial intelligence, and my colleagues, both women and men, are working together side by side to push the boundaries of knowledge. But women have a lot to give to the field, and so it's really exciting to see that as the field expands, we do see um, increasingly more participation from women as well as from men. So I don't really separate between the contributions of men and women in the field, because I think what's important is the contributions. And there are extraordinary scientists who are women, and there are extraordinary scientists who are men, and we need to all work together in order to make the world a better place.
Absolutely. And that is also the core value of the VinFuture Prize, which seeks to celebrate innovation in its entirety. With the recent recognition of the AI revolution for the VinFuture Grand Prize, this has exemplified this by honoring all the core pillars contributing to this technological advancement, as well as recognizing both the academic and industrial contribution, and honoring and acknowledging the contribution from both laureates of men and women. So now for the last questions, how do you think recognition like the VinFuture Prize can further accelerate the development of AI and robotic solutions with impactful applications globally?
We are at the point in time where the field of AI is just beginning to make its impact on the world. And so celebrating these extraordinary colleagues who have for the field is inspirational. And I think it energizes the young generation to participate. It energizes the young generation to know, to learn, to contribute. And so I think this is really extraordinary.
Thank you, Professor Rus. And with your addition to the VinFuture Prize Council, I have no doubt that the VinFuture's commitment to recognizing and honoring the technological advancement benefiting humanity will be further strengthened. And I also would like to take this opportunity to remind our audience and nominating partner that the VinFuture Prize nomination portal for the 2025 VinFuture Prize will remain open until 2 p.m. on April 17, 2025. Please refer to the link below for more information. Keep supporting the VinFuture Prize and the Unveil the Future podcast by hitting the like and subscribe button below. And this wraps up the conversation for today. I will see you in the next one.